Hi guys, for today's assignment, other than the Math Excel that was assigned last week, last Thursday to be exact, that's due today. Okay, I'd also like you just kind of finalizing our water cooling um, activities. So I just want you to download this and print it out and fill it out. Again, if you don't have a printer or it's not working for you right now, any paper will do. I just wanted to help you guys get your axes set up. What you're going to be doing mostly today is drawing a rough sketch of some of these situations that we've observed with water. And then in the last section, you're going to be just writing a brief summary. So in this section, this is just reviewing what we did last week. So just to help you set up what the graph's going to look like here, think about what that looked like. This was basically boiling water cooling to room temperature. Okay, so this is how that was set up. I'm gonna make a mark up here for where water was boiling. What are the two temperatures, degrees in Fahrenheit? So boiling could either be considered 212 degrees Fahrenheit or 100 degrees Celsius. Okay, and let's just say that this is your room temperature right here. Okay, so for the first part of this activity, when you turn this in, all I want you to show me is what you learned last week about how it looks when water cools to room temperature. That's the first one. Second one, in your assignment, you have a new link. And what you're going to observe, and I have three phases here, that's not quite true. Even though water does have three phases, solid, liquid, gas, the video you're going to watch is H2O as a solid, so that's ice, as it heats up, as it transitions from a solid to a liquid. The video that you're going to watch here does not have to do with its vapor form, okay, as a gas. So just want to help you set up the axes for this one. So it's just going to go from water in its solid phase. In this video, let's kind of make the scales good here. The video you're going to watch starts with water. Water starts to freeze at 0 degrees Celsius, but as a solid, it can continue to get colder. And so you're going to see your video start at negative 40 degrees Celsius, and then it's going to heat up and begin to boil, and we know it boils at 100 degrees Celsius. Okay, so that's the setup for that. What I'd like you to do before you even watch the video is take a guess at how water is going to heat up. It's going to start right here at negative 40 degrees Celsius. It's going to heat up to boiling, 100 degrees Celsius. See if you can figure out how that graph's going to look over time. Okay, and then down here, in this one, you're going to watch the video, maybe once, maybe twice, maybe 3 times, just to get an idea of what actually happens when water as a solid heats up. It's going to start at negative 40 degrees Celsius, and it's going to go up to 100 degrees Celsius. And so on this one, you're going to observe and sketch what actually happens. So do this one before you watch the video, do this one after, and then down here you're going to just write a little summary of what you're observing and any surprises or things you knew. Yeah, H2O is kind of a interesting compound. I ask your chemistry teacher, I don't know enough about it, but I think it might be the only compound that as a solid it has more volume than a liquid. So as H2O transitions from a liquid to a solid, it actually expands, where most other solids, as it moves from a liquid to a solid, it contracts. So just your math teacher knows a little bit, but ask your chemistry teacher if you want to know a little bit more about that. Okay, guys, good luck on this, and see you soon.